Hello, this is Channel Easy Self-Host. In this video, we are going to talk about HTTP proxy. First on why I'm always using the HTTP proxy for every self-hosted web service. Then I'm going to show you how to easily use HTTP proxy to achieve these benefits with multiple popular proxy choices. Let's get started with why we should use HTTP proxy for our self-hosted applications. The number one benefit of using a proxy is definitely for the ease to manage our services with domain-based routing. We usually run a bunch of apps on one server. If we just expose them onto the server's IP, each app will need a dedicated port number. So we end up with a ton of ports to remember. Plus, it makes your browser's address bar look super cluttered, since they will only hide the standard ports of 80 and 443. Using a domain name can help that you don't need to memorize the IP address, but you are still going to deal with the port numbers. When we use a proxy server, it's the only one exposed to the server's external IP, sticking to the standard port number. It can route different domains to different apps, so you get to give each app its own easy-to-remember subdomain. One great thing about domains is that you don't pay extra for creating subdomains. The second benefit is the simplicity to protect all your self-hosted applications with encryption. And you won't see the unsafe sign for your self-hosted sets on your browser anymore. Once you configure the HTTPS setting for your proxy server, all your applications get the encryption. So you don't need to configure HTTPS for each of your apps, and many of them don't even support that. What's even better is that many modern proxies offer integration with free certificate provider like Let's Encrypt, so you can get certificates automatically. And some of them even integrate with common DNS providers like Cloudflare, so even if your server is running in your home network, you can still get certificates automatically. I'll show you some examples later in the video. The third benefit is that you can add access control on your proxy server. I have a video about setting up Authelia on the proxy server for authentication. You can check it out if you want to do this. Many applications don't have login support, so you can protect them with this method. And there are other apps like File Browser that lets you use proxy-based authentication instead of their own login. So now you have a single sign-on system that gives you an uniform experience among multiple apps. These are the three most relevant benefits for self-hosting. There are more common benefits like better performance since proxies have the compression and caching capabilities. And also proxies have their logs that you can get insights on who accessed what. Then I'll show you how to use three popular proxy servers for your self-hosted applications. In these examples, I'll show you how to do domain-based routing and how to set up HTTPS easily with Let's Encrypt and your domain's DNS provider. You will need a domain name for these examples, and you can reference my first tutorial on how to get a domain. The three proxies I'm going to show you are Caddy, Traefik, and Nginx. Each of them has their own unique features, and there are also trade-offs. Besides the three, I also had a video about Nginx Proxy Manager, which is a graphic UI-based proxy service powered by Nginx. Now let's get started with Caddy. Caddy is my personal choice for its simple and elegant configurations and its relatively simple integration with DNS providers. Now let's get started with setting up Caddy for two self-hosted applications here using Docker Compose. For the Caddy image, I'm using the image built by myself. I'll get into this later why I'm not using the official image. For the port section, we're exposing port 80 and 443 for HTTP and HTTPS. Note that we are not exposing ports for our two applications since Caddy will reach them using the Docker network within the server. For the volume section, we're using a volume to store the data generated by Caddy. The data will include the certificates and logs which are worth persisting. We're also mounting the Caddy config file to the container. I'm going to show you the configuration in a moment. I'm also setting an environmental variable DNS provider token. This is for Caddy to get certificates through DNS challenge. I'm using Cloudflare as my domain DNS provider. To get this token, you can go to your profile in Cloudflare. In the API Tokens tab, click Create Token and choose Edit Zone DNS. Here in Zone Resources, choose to include the domain you want to get the certificate. Then you can keep clicking Continue to create the token. At this page, make sure to copy your token since you won't be able to access it after closing this window. Back to the Docker Compose file, you should put your token after the equal sign here. Then let's go take a look at the Caddy config file. Like I said, the Caddy config is easy to write and understand. We can group all the subdomains together. For each subdomain, we define a rule to proxy a subdomain to a Docker service with a port number. And on the top, we define our TLS setting, which is used to get certificates. Here, my setting is to get it with the DNS challenge through Cloudflare. And then I provide my API token set in the environment. Caddy supports DNS providers through its plugin system. And to add plugin to Caddy, you need to compile Caddy with the plugin code. This is not very user-friendly since people who don't know how to code will find this confusing. That's why I have my personal Caddy image built with a list of popular DNS provider plugins. I'm using the official recommended way to build the plugin. I host this image on GitHub and you can just use it by specifying this image in your Docker Compose file. Now we can go to the command line to start Caddy and our applications. Let's first go to the directory that has our Docker Compose file, and then run the command docker compose up-d. Now everything is up and running. Before we go to test our applications in the browser, make sure that your DNS points your subdomains to the server IP. You can either do this in your public DNS provider or modify the local DNS server if you are using Pi-hole or Edgard Home. After that, we can type the domain name for our application. Here I'm entering the domain name for Vault Warden. I'll also test the domain name for Memos. So they both work and we can notice that HTTPS is enabled. That's all for using Caddy. Now let's move on to use Traefik to do the same thing. Traefik has a feature that it can monitor your Docker services, so it can handle proxy rules automatically. Using this, you can have the proxy rules configured in the Docker Compose file, and it's super convenient. For Traefik, we can use the official image because it has popular DNS integration built in. We can configure the Traefik server using the commands. The first argument is for enabling the admin panel, but we actually don't need it here. The second argument is required since it lets Traefik to monitor the Docker services. The third argument is to let Traefik not connect to the services that don't enable Traefik. So it means we need to explicitly enable Traefik in our service setting. The entry point arguments define the HTTP and HTTPS port. We just set it to standard ports. The rest of the arguments configure how to get a certificate using the DNS challenge. As you can see, I set the provider to Cloudflare, and I also set my email to receive notifications for certificates. Then for every proxy server, we need to expose port 80 and 443. We also need to set the Cloudflare API token. This environment name is defined by Traefik, so other providers will have different names. For the volume section, it's important that we mount the Docker socket to the container so Traefik can monitor the Docker services. Also, the ACME volume is for storing certificates. Moving on to the application services. The difference is that we need to add a label section to add the proxy setting. The first argument enables Traefik to proxy to this service. The second argument configures the domain name we want to use. The third argument lets Traefik to use HTTPS for this service. The last argument tells Traefik to get a certificate using the config we provide in the Traefik arguments. And it's the similar for other services. I'm going to skip the command line part and the testing part as it's the exact same with the Caddy example. Now let's try doing the same with Nginx, the most popular proxy server in the world. But personally, I'll recommend you to not use it for self-hosting. Because its configuration is hard to get right without experience, and there's no built-in support for automatically getting certificates. The Docker Compose for application services is the same with the Caddy example, since we'll have a dedicated configuration file for Nginx. The Nginx service uses the official image. It also exposes the standard ports, and it mounts the configuration file and a volume to read certificates. What is different is that I add a depends on section. This is a hack I create to automatically get certificates in this example. So we'll have another container certbot to get certificates and refresh it regularly. It uses the official certbot image with support for Cloudflare DNS. I customized the container's entry point to get a certificate for my domain name and refresh it regularly. This uses the server command line tool provided by the image. Here we need to specify the Cloudflare API token in a credential file. And I'm getting the certificate using a wildcard so all subdomains can use this certificate. I add a health check for this container to test if the certificates are presented. The Nginx service will wait for this check before it starts, so it won't start without certificates. Now let's look at the Nginx configuration, and it's complex compared to Caddy. There are some general settings you can just reuse. Now it's the SSL setting to read certificates from the directory we mount our certificate volume. Then it's the proxy rule for each of our applications. The first line tells Nginx to use HTTPS. The server name defines the domain name we want to use. The location section for root path defines the upstream we want to proxy to. The resolver line here is to let Nginx to use the Docker resolver so it can recognize our Docker service name. And the next part is the upstream service address. The last section is to redirect every HTTP request to HTTPS. So users that hit the HTTP site first will be redirected to more secure connection. To start the Nginx example, we also just need to run docker compose up-d. It will take longer because the Nginx service will wait the server to acquire certificates first. The end result is the same with the other two examples. That's all for this tutorial. Please consider subscribing for content like this. You can find the configuration files in this video on GitHub and the link is in description below. Thank you for watching.